Hello, my name is Morgan West. My project is based on sinkhole data in relation to population data in census tracts. So I started the creation of my census tracts by going to the United States Census Bureau website and finding the Tennessee census tracts shapefile on their website, located here. And then I had to import it into QGIS, and I changed the CRS of the shapefile and of my project so that they would both be the same. Then I needed to get my population data in relation to the census tracts, so I went to another section of the United States Census Bureau website and found an American Community Survey, ACS, that showcases the total population and margin of error in census tracts. I then added this to my QGIS file, but before I did that, I had to slightly reformat the data. So I can show you that in QGIS here. If I open the attribute table up, you can see I've got GeoIDs and the census tract IDs, total population, the margin of error on total population, and then this custom field I made called GeoTract. And all this does is it is a merger of the GeoID field and the census tract field into one, so that when I add this on, it appropriately links the population data to the right census tracts and doesn't jumble them up. With that done, I was able to stylize my data to showcase the densest populated areas based on census tracts. And so in the center of Tennessee, you can see there's a large majority of the densest populated tracts. There's some over at the southwest side, near Memphis, and there's some that kind of follows up in an arc around the east side of Tennessee, but the largest majority is in the center. Now that I'd added in my population data, I needed to figure out my sinkhole data. This proved harder to find, but I was able to find some sinkhole data related to county areas on sinkholemaps.com. And so they have a list that shows the counties and the number of sinkholes and some additional data. But I pulled the county list and the number of sinkholes per county into a new CSV file, which I then added some extra information to and reformatted so that I could appropriately sync it up to my population data. And I can show you that in the QGIS attribute table as well. I've got the county FIPS codes, which is going to be the basis for the linkage between the shapefile and this data. Then there's the sinkholes per tract, which I took the number of census tracts that make up a county and the total number of sinkholes in county, and I divided the total number of sinkholes in county by the number of census tracts that make up a county to get a even distribution of sinkholes across all the census tracts. And since this did not provide me with whole numbers to work with, I decided to round these down, as rounding them up felt like it would take it farther from the total number of sinkholes in the county. Also, I'm aware that this introduces a margin of error for all sinkhole counts, as the rounded numbers do not exactly add back up to the original number of sinkholes in the county. But this is why I included the total sinkhole count along with the number of sinkholes in the census tract. Because if you use the Identify Features tool in QGIS and you click on any of the census tracts, you can see the total population in the census tract, the margin of error, of population in the census tract, along with the sinkholes per census tract and the total sinkholes per county. My second visualization shows the sinkholes in county form. It groups them by county form, even though they are set per census tract. So when you see the groupings, it's showing the density related to the counties within the census tracts. And similar to the population data, there is a large majority of sinkholes near the center of Tennessee. There are some that kind of curve up with the east side of Tennessee, but for the purpose of this project, the main focus is in the center of Tennessee, where the densest population and densest amount of sinkholes lie. Now, with the results that can be found, I was thinking that the state could use these two visualizations and overlay them to see that in the center there is a large grouping of the population of Tennessee per census tract, and the largest grouping of sinkholes in census tracts based around the counties, and that these areas or sectors would be the best to keep surveillance of, to watch over, because there's a greater chance, due to the amount of sinkholes in the area, that one of them could collapse. And because of the large grouping of people in the area, it's more likely that someone could get hurt, or the infrastructure in these areas where population is denser, and likely it's more urban, it would cause greater damage to the infrastructure. So there are other places they could look, but it would be less efficient, and so I think the state could use this as sort of a way to measure efficiency and see where they should be pointing their resources towards. And for some perspective, I wanted to just quickly run over some news reports I had found. 3 of these are within 2024. One is from 2022. So this one is a giant hole opens in City Hall parking lot in downtown Clarksville. And there is another one in McMinn County, where 2 large sinkholes opened up right beside a roadway. Another was at a farm near Knoxville. A sinkhole had opened up in 2023. They had filled it in, and then it had reopened again in 2024. And the last one is in let me see, I believe this was in Knoxville as well, yes. And so this lady bought sinkhole insurance because she knew she was in a sinkhole-prone area, and a sinkhole opened up below her house, and so she's been in a constant fight to keep her house repaired and stable because of the sinkhole. And so sinkholes do pose a fairly decent risk to Tennesseans, and I think the state should create a similar system as to what I've made in this project to, again, figure out where they should be putting their resources and how they can most efficiently help people if sinkholes do open up. Thanks for viewing my presentation.